So anyway, okay, so again, this is the exam from 2017 summer, so exactly 2 years ago, roughly, um, when this exam was given. I'm going to move the bubbles here out of the way. What bubbles? Those bubbles there, they get quite annoying. Okay, so first one, create a MATLAB function. Now, if it says create a MATLAB function, that means you need to create a user-defined function that is called myAbs that performs the same way the built-in absolute values function performs without using that built-in function or by taking the square of the square root, or actually the square root of the square. In other words, the function should take as an input any vector or scalar and return the absolute value of either the scalar or each element of the vector without ever using the abs built-in function or the square root function. Okay, so this is a user-defined function. I am going to copy all this information here and come down to the bottom, and I'm just going to include my function down here in the bottom of the M file. I guess maybe what we should do is do this in I will go ahead and do it in the M file. There's not much difference between here and the live editor. So I'm going to just copy this down here. So this is our first function. Whoa, good grief, that was loud. Hang on, I got to turn that down. Whoa, how'd that get up to 100%? Oy vey. Okay. So we're going to do our function down here. And again, it's just a function, so we need to have some kind of an output variable. I like to use results is equal to, and this was supposed to be called myAbs, and it's going to receive an input. And then I like to copy all this down so it tells me what I'm looking for. And if in the future I want to hit help myAbs, it'll tell me what it was supposed to be doing. So there are several ways in which this can be done. Sorry, I had a stretch there. So I'll show 3 ways that I know of based off of the material that we covered since the last exam. The find function was in, was that this much or this? I think the find was in this section. Okay, well, we'll do it anyway. First off, I'm going to zero out my result vector results and just set it equal to 0. Just to give me an initialized vector. And then we're going to do a for, oh no, wait a minute, we need to find out how big of a input variable we're being sent. So we're going to find the size of x. And then we're going to go for I equal 1 to, I don't know, it doesn't really matter. We're going to go from 1 to rows. And then we'll also do a nested for loop here and go from j equals 1 to number of columns. And then we're going to say if, and then our input is x, I sub j. If that element number is less than 0, which means it's negative, right? Then we're going to say that the results, actually, we want to come up here and assign results to our input vector so that it just copied it into the results. This way, if we find one that's negative, we'll come in to that position and say that that is equal to -1 times the element at that location. And then do an and an and. and then also end our function. So this here is going to go column by column. Take the first column, look at every value in that row. Oh, sorry, first row, and look at every value in the column. If it's negative, it's going to multiply it by -1. No, it's not. Make sure and put that around so that it takes a -1 times that. I guess it probably would work either way, and which will make it positive, and it'll just do that for all of them. So that's one way to do it. We will do another way and comment it out. Oops. Another way we could do this would be the same thing. We'll set up our resultant vector to be equal to our input, and then for I equals 1 to the length of x, if x sub I is less than I want to make this a column vector, so we'll make sure we get all of them. Less than 0, then we'll do the same thing. The results of I is equal to -1 times x sub I. Yeah. So that should work too. Because if we just do the one number, it will come down and then go back up and come down and go back up and come down. So that's another method to do it. We'll comment that out. And then one more method would be again, we'll start off by results equals x. Set is equal to find x less than 0. Result location is equal to x set times -1, and that should do it too. So any one of them is a valid method to do that. And you notice each time it got shorter and shorter in the programming. Okay, and then we'll come up here and now and test that. We're going to just borrow these. And do my abs x. And we run it, and yay, no mirrors, and you notice no negative signs. If we come down here and hide this one, we don't get data displayed that we don't want. So there we go. So we have 5 and columns 1 through 10, 5. Okay. Any questions? Cool. We move on to question number 2. Solve the following set of equations using both matrix inverse and matrix left division. So your answers are correct by multiplying out the matrix. Okay, so this one we have to define that our coefficient matrix. We have 4, 2, minus 5, 1, 2, 3, 7, 10. Minus 5, minus 2, 5, 9, and 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 4, 6, 8. And I'm kind of, yeah, I like my, to be right, but also like them to line up pretty. Yeah, I know. It doesn't make any difference. It's still the same. And then our resultant vector needs to be a column vector. So we're going to have minus 3, 69, 42, and 60. Okay, so the first one was matrix inverse. Inverse, you can spell this. Matrix inverse, there we go. So X is going to equal the inverse of A times B. And then, right? Yeah, that's right. And then left divide is going to be X left is going to be A divided by B. Right? Right. And then to check them, we will multiply out. We'll come up here and multiply these out. A times X and A times XL. Boom. And we got 1, 2, 3, 4, 1, 2, 3, 4, minus 3, 6, 29, 40. So that proved that we did it correctly. Okay, that was the give me problem. That's probably the easiest problem on here. Look at that, 15 points. Man, that was. Okay. Suppose you have 8 cousins. Name cousins 1, 2, 3. Well, your aunt and uncle was sure lax with the names. With ages as follows: 7, 12, 17, 2, 9, 9, 6, 17. Use a single fprintf statement to print the following line for each cousin. Cousin's number is cousin age years old. Wow, this one's tough too. Okay. So we're gonna say cousins numbers, there was 8 of them, so 1 through 8. And ages is equal to 7, 12, 17, to, you dropped a 1. Oh no, you didn't, you put a space in there, you idiot. 7, 9, 6, and 17. And then I'm just going to create my little table vector um, um, is going to be, and then we want to have 2 rows of data. So there's the first row, and the second row is going to be ages. And then we'll do a little f, print f. Um, 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 so it's, whoa, there's no p in cousin. Serious. I looked it up. It's not there. Cousin number, and then we'll have a placeholder here, and we have only single digits, so we'll do 1.0f is, and then here we have 2, so we'll do another placeholder of 2.0f. Years old, and a new line in that, and put our table in and close it, and voila, cousin number 1 is 7, and cool. Questions? Um, um, okay, I either put you guys to sleep or you got no questions. Okay, so an aptitude test has been developed to determine what area of engineering a student should choose. Based on a final score from the exam, they will be recommended to go into mechanical engineering if they score 80 to 100, civil engineering 69 to or 60 to 79, chemical 40 to 59, materials engineering, and computer. Write a program. Okay, so that says a program, not a function. So it has to say function to be a user-defined function. So this is basically just write code that would prompt the student to input their score from this aptitude test. Then using if-else statement, display to the student the engineering they should consider. Okay, so first off, we need to get a score from the user. Input we'll be polite, says please enter your score, space, comma, this, and we'll suppress the output to the screen. And then next we'll check the score. If the score is, okay, the first one is 80 to 100, so we'll go greater than or equal to 80. Then we'll just display mechanical engineering, and then they can come work for me and design pigs. Okay, then else if score is, the next one is greater than or equal to 60, and then it's just, from this point, it's just repetitive. You will be a civil engineer. Design things that don't move. Oops, elsing. I'm elsing. Oh, else if what? Oh, there. So you guys should have spoke up and said, "Hey, stupid, that's not supposed to be a capital." And score is, and the next one is chemical engineering at 40. So greater than or equal to 40. Then display chemical. Engineering. I think that's right. And then else if the score is greater than or equal to 20. materials.
Okay.
And then a final else computer. And end. Okay, and I scored a 37. That should come out at materials engineering. Woohoo! Woohoo! Okay, everybody do a happy dance. Okay. Yeah, I'm tired. Let's try, let's see if we can get a civil engineering at 70. Okay, cool. Oh, it works. Okay, the next problemo is to create a vector of angles from 0 to 360 in steps of 30 degrees. Okay, so theta is equal to 0 by 30 to 360. Yeah, I seen it. I'll go fix it. My finger slipped off the shift button. Okay, part B, create vectors containing the tangent, the cosine, and of the angles from part A. Okay, so let's do tangent of theta is equal to tan, and because it's in degrees, we put a D. That actually got a few people on the exam, in case you're curious. And then cosine theta is equal to cosine D theta. Okay, so use fprintf, create a table that lists the angle, the tangent, and the cosine. Use the display function to generate column headings. Make sure the columns in your table are uniform. Oh, that one got people too. Format the number such that the tangent displays 2 digits after the decimal and the cosine 3 digits. Okay, so we're going to do a display. Create functions table. And then we'll do our column headers. This will be theta. This would be tangent of theta and cosine of theta. How come you didn't capitalize the tangent? I'm sorry. Okay. So there's our column headers. And then we'll do an fprintf. Now there's many ways to format this line so everything lines up nice and pretty. I personally, if it's a short list like this, I just use spaces. So our theta is going to be 3 digits. We got 5, so I'm going to come out 1 space and do a percent. We get 3, so we're going to point 0. And it's an F. And then we'll come over here a little bit and do a percent. And then, okay, so we want tangent has 2 digits after the decimal. So we'll have a percent. So 2, 3, 4. So if it displays as 0, 0.2f, and then the cosine is going to be 3 digits. So we'll do cosine 5 That counts for the 0 on the left of the decimal point, and the 3 digits after the decimal point. 3F, new line, comma, and then I'm just going to create my table in here by using square brackets, and we'll put in first our theta, followed in the next row by our tan theta, followed by our cosine of theta, square bracket, and voila. Oh, look at that. Isn't that nice and nasty? Okay, so we didn't take into account our negative signs, so there's 5 there, so we need to change this to a 5. Boom.
Can you explain the whole 3.0 and 5.2 thing? I've tried to understand it, and I keep getting lost on how that formats exactly.
I certainly can and would love to do so. Okay, so you notice here when this was at 4, my rows are not straight. Okay, so what this means is this tells MATLAB to set aside 3 character spaces to display that number. Now that includes
even though all 3 spaces aren't used.
Even if they're not used, but that includes decimal points and signs. So, and the number on the right side of it tells how many decimal points to display, and then the letter is the format. Okay, so for 3 here, 3.0 is telling it to save 3 character spaces with nothing on the right. So you'll notice my thetas are all lined up nice and perfect. See, and the way I do this is I'll print it off once, and you see how things are goofy. Then I'll come in here and look. Oh, look. Okay, I forgot to count for a negative sign. So there's 1, 2, counting the decimal, 3, 4, 5 digits here or characters that need to display. So if I change this to a 5, and I still want the 2 decimals on the right, now everything over here is lined up nice and pretty. And then the same over here. We got 3 on the right side. The decimal is 4. The 0 is 5. The negative is 6. So if I change this to a 6, that'll give me 6 character spaces plus the 3 decimals on the right. Not plus, but including 3 decimals on the right side, or 3 digits on the right side of the decimal. And they're all nice and pretty. Now everything is a nice square, and we can just bring that over a little bit, put it under the column header. That's how I like to build my tables.
Oh, okay, sweet. No, that makes a lot of sense. Thank you.
Yep, no problem. Oh, and see in the first. Oh, okay. So I use theta instead of angle, and if it says it should look something like this, so I took the something part very literal and made it look better. So yeah, so cool, great question. You should get bonus points for that. Okay, problem number 6. Prompt the user to pick one of the 3 trig functions, sine, cosine, or tangent. You can use either menu button or the input function. Part B is to plot the chosen function for values from x equals 0 to 4 pi. Choose a spacing to ensure a smooth curve. See, a lot of people skip that line too. And be sure to include a title showing, include a title showing what? That was a dead statement that didn't get finished. It's like my thoughts that died of loneliness. A hint: use switch case, structure, or an if else. Okay, so first thing, we know we're going to have a theta regardless of what we choose. So we'll just go ahead and it's going to go from 0, and now a smooth line. If we're not plotting it in a table, the more points we can give it, the smoother our line will be. So if we put 400 points or 100 points between, not that we want to multiply by pi, That should give us a nice smooth. What? Should give us a nice smooth. Okay, so let's do this with a menu. I like menus. Menus are fun. So we're just going to have some kind of variable. I'm just going to call it func, or which trig function I want to. I try to make my variables meaningful, so when I'm using them later on, I know what it was I was looking for. So we'll go to menu, and we'll type in something nice and polite. So please, pick a function, and then we'll give it the options that we want it to choose from. Either sine of x, cosine of x is the next one, or tangent of x. We gotta have a, well, no, you were right. I was right. I just forgot the first one. There we go. Okay, and you guys did cover menus in the homework, right? I do remember there's supposed to be a problem in the homework for picking a geometric shape and having to calculate how many degrees there are in the angles or something like that.
Yep.
Okay, so now let's use a switch. Hey, somebody turn the lights on. How do you spell switch? I think there's a silent Q in there somewhere. Okay, so we're going to look at the func variable, and we'll do a switch. So if it's case 1, we're going to say that y is equal to, and what? It's a sine. Sine of, we call that theta. And we're going to plot theta and y. Sorry, I had a brain fart there for a minute. Title is going to be, come on, hit the right keys. There you go. Sine of theta. Actually, we put X in the menu, so let's match our menu. Our X label is going to be theta, and the Y label is going to be sine of theta. We seem to be using that quite a bit. That's because it's in the problem. Sine of x. Okay, and then this is where we cheat, and we're going to say, hey, we want to borrow you for a minute, can we? Yeah, that's fine. Okay, and so now case 2, which will be if the second option is picked, is going to be cosine, and cosine. Cheater. And then, oops, Control V, case 3 will be tangent. Poof, and here's our little menu box. Isn't that cute? Isn't that just the cutest menu box you ever did see? Hey, let me move. It won't move. Okay, so let's look at the sine of x. Poop, there's our sine curve. Let's get rid of you. Isn't that cool? Say, yeah, that's cool. Yeah, that's cool, man. Okay, and our cosine. And look how nice and smooth those curves are. Man. And tangent. Wink, wonk, wink, wonk. Okay. Any questions on that problem? It was pretty easy. You could do it also with an if-else. Up here somewhere it said use either menu buttons or input function or yeah. Okay. And then the last problem. This one here was kind of an interesting problem. So we need to use a nested for loop, okay, for loop to generate a 7x9 matrix where each element has its row number in the tens place and the column number in the ones place. Here's an example of what it should look like. Okay, so we're going to do a for loop, and so I want to go across each row first. So I equals 1 to 7 rows. So the first row for each column, we'll do another for loop for j equals 1 to 9. We will say that our matrix at that point equals okay. So the row number has to be 10 times its value. So we'll do because it's in the tens place. So 10 times I, and then if we add the column, that should give us what we're looking for. And oh, it didn't work because you didn't display it when you were done, dummy. And there it is. 11, 21, 31 to 71 and to 79. So that was a very easy test. I can't guarantee that the exam I give next week will be that easy, but it won't be uber hard either. Any questions? Anything you want me to go over in more detail? Anybody still awake?